video, we are going to explain about chronic kidney disease prediction using CNN, LSTM and Ensemble model. Chronic kidney disease is a progressive condition characterized by the gradual loss of kidney function over time. It can be caused by various factors such as diabetes, high blood pressure, kidney infection, and genetic disorders. CKD is a global health concern affecting millions of people worldwide. Timely diagnosis and proper treatment are crucial in preventing or delaying the progression of this chronic disease, ultimately reducing the need for life-saving interventions such as dialysis or renal transplantation. Our main objective of this project is to develop and evaluate the deep learning algorithms including convolutional neural network, long short-term memory, and an ensemble model with CNN and random forest to accurately predict the occurrence of chronic kidney disease. By leveraging the chronic kidney dataset from the Kaggle repository, we aim to train and optimize these algorithms to provide the reliable predictions based on the relevant features and medical data. The basic requirements needed to build this project are Windows as an operating system, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements are Python IDEL with version of 3.7. To implement this project, we have designed these following modules. Upload chronic kidney dataset. In this module, we will upload the dataset to application and then plot number of non-CKD and CKD patients graph. The second module is pre-process the dataset. In this module, we will read the dataset and then replace the missing values with 0 and then normalize the dataset values and then split the dataset into training and testing part. Here we take the 80% of dataset for training and 20% of dataset for testing. The third module is Run CNN algorithm. The CNN means convolutional neural network is used to training the data. Is trained using the provided dataset, learning patterns and features relevant to predicting the chronic kidney disease. The trained CNN model is then evaluated on testing data to access its prediction accuracy. The fourth module is Run LSTM algorithm. This module focuses on training the long short-term memory algorithm using the training data. LSTM models are particularly effective for capturing the sequential dependencies in data, making them suitable for time series or sequential medical data. The LSTM model is trained to learn patterns and relationships within the dataset, specifically targeting the chronic kidney disease prediction. The fifth module is Run Ensemble Random Forest. In this module combines the optimized features extracted from the trained CNN model with random forest algorithm. The purpose is to enhance the prediction accuracy by leveraging the strengths of both CNN and random forest. The features obtained from CNN model are used to train a random forest model, resulting in an ensemble model that combines the predictive power of both algorithms. The sixth module is Comparison Graph. In this module, we will plot the accuracy graph between all algorithms. And the seventh module is Predict Disease from Test Data. In this module, we will upload the test data and then ensemble model will predict whether test data is normal or contains the chronic kidney disease. For execution of this project, double click on the run.bat file and we get the screen like this and click on Upload Chronic Kidney Dataset and select the kidney disease and click on Open button. And we get a graph like this. Here it represents the x-axis with CKD and non-CKD labels and the y-axis represents the count for CKD and non-CKD. And then close this graph and click on Pre-Processed Dataset. Here the dataset is pre-processed and then we get the records of total is of 400 and the trained dataset is of 320 and testing of dataset is for 80. And then click on Run CNN algorithm button. and we get this confusion matrix. Here x-axis represents the predicted class and y-axis represents the true class. Here it represents the true positive, false positive and true negative. And then close this graph. We got the accuracy of CNN as 98.75, precision as 98.9, recall as 98.48 and F-score as 98.7. And then click on Run LSTM Algorithm button. Here we got the confusion matrix for LSTM as this, and here x-axis represents the predicted class and y-axis represents the true class. Here this box represents the true positive, false negative, true false positive and true negative. Here the accuracy of LSTM is 93.75, precision is 94.33 and recall 92.8 and F-score is 93.45. And then click on Run Ensemble Random Forest. Here we get the confusion matrix for Ensemble CNN with random forest as like this. Here x-axis represents the predicted class and y-axis represents the true class. Here the black box represents the true positive, green box represents the false negative, yellow box represents the false positive and violet box represents the true negative. The accuracy of Ensemble CNN with random forest is 98.75, precision is 98.2, recall is 99.03 and F-score is 98.63. And click on Comparison Graph button. We get a graph like this. Here the x-axis represents the algorithms we used in this project and the y-axis represents the values assigned for each technique and this algorithm. Here blue represents of accuracy, orange represents of S-score, green represents of precision and red represents of recall. And click on Predict Disease from Test Data and then select the test data from this folder and click on Open button. And we get the result as for this test data. It is predicted as chronic kidney disease, and for this test data it predicted as not chronic disease. In this way we can predict the chronic kidney disease using CNN, LSTM and Ensemble model. Finally, I conclude that the project successfully employed the deep learning algorithms like CNN, LSTM, Ensemble with random forest and the chronic kidney dataset to accurately predict the chronic kidney disease. The results offer potential for early detection, better patient outcomes, and integration into clinical practice, necessitating the additional research and validation.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.